we will see the difference between these two. And closed loop control system. Okay. What is open loop control system? Just see a simple block diagram. First, open loop control. Input is given to one controller. Output of the controller will go to some controlled process. And finally, the output of the control process is the output. And this is output. So this is a open loop control system. Okay. Now the thing which is missing. Now if we take a look at the closed loop control system, then there will be a feedback from the output to the input. Input RT, output CT. This is my feedback. This is my controller and control process. Okay. So this is a closed loop control system. Actually, to get more accurate control, controlled signal CT should be feedback and compared with the reference input. Okay. So that same thing is happening here. The controlled output CT is being compared with input RT. Okay. And then the error signal which is detecting here, that error signal is going to one control function and the output of the another control function. We can represent these two by a single block also. Okay. There is no problem in representing this as a single block. Okay, so this is a closed loop control system. So what are the differences which they are in closed loop and open loop control system? See, just write a note. Closed loop are more complex. More complex than open loop. Than open. Okay, they are more complex than the open loop control system. In case if non-linearity is present in open loop control system, then that open loop control system will degenerate. Now, but what will happen in case of closed loop control system? If non-linearity is present, those non-linearities will decrease with the time. Okay, that means if closed loop control system try to reduce the non-linear effect. Okay, noise is also reduced more in this. It is more stable, but the gain is less. Non-linearity effect reduces in closed loop. Okay. Now we have seen open loop and closed loop control system. In closed loop control system, there is a presence of feedback in the system. So the next topic will be feedback and its effect. How the feedback will affect the system characteristic. Okay. First, the type of feedback. Positive feedback, and second one is negative feedback. Okay. If the output is added with the input, then it is a positive feedback. In this case, Cs upon Rs is equal to G upon 1 minus Gh. Okay. Now, in positive feedback, if we look at the positive feedback, the effect on gain. Overall gain increases. System becomes less stable. Since gain into bandwidth product is constant, since gain increases, bandwidth decreases. Okay. Effect of noise increases. Because since it is a positive feedback, so noise, instead of getting subtracted from that, it will get added up. Okay. So these are the effects of the positive feedback system. Now if we take a negative feedback system, so all those things which were happening in positive feedback system, the reverse things will happen in negative feedback system. Generally, the systems are made negative feedback systems in nature, because a system to exit, it should be stable, but system is becoming unstable in case of positive feedback. So Cs by Rs in case of negative feedback system is G upon 1 plus Gh. Okay. Okay. In case of negative feedback, first, overall gain reduces. Second, system is more stable. Since gain reduces, so bandwidth will increase. Effect of noise decreases. Okay. It becomes less sensitive. Okay. So these are the 4 effects of the negative feedback system. Now what is sensitivity? Very important. Generally can come as a 1 mark question, or sometimes can be 2 mark questions also. Write down sensitivity of overall gain of the system with respect to some parameter is defined as delta t by t upon delta g by g. Similarly, this is delta t by t by delta h by h. This is percentage change in t upon percentage change in g. Okay. Suppose the overall gain of a system is denoted by t. Let's suppose t equal to g upon 1 plus gh. Okay. Then sensitivity of t with respect to g is equal to delta t by t by delta g by g. Simple. So I can write this as delta t by delta g dot g by t. This is equal to 1 by 1 plus gh. So sensitivity reduces by a factor of 1 plus gh. Okay. So this was the sensitivity issue which is there in presence of feedback in closed loop control system due to presence of feedback. Okay. Now if gh is a positive constant, the magnitude of sensitivity can be made small. Okay. If gh is positive, but if gh is negative, and if it is then sensitivity will be reduced in other way. Sensitivity for open loop system is 1. Because t for open loop system is g, then delta t by delta g is equal to 1. Okay. Thus sensitivity of t with respect to g is 1. Sensitivity for a closed loop system with respect to feedback sensitivity of closed loop system with respect to feedback factor h, that means s t with respect to h is delta t by delta h dot h by t, which is equal to minus gh upon 1 plus gh. Okay. So this was the sensitivity with respect to h. Note, the amount of increase in bandwidth is new bandwidth B new is equal to old bandwidth 1 plus GH. Okay. So this was one important note which can be directly deduced from the gain bandwidth product. So this small topic completes the effect of feedback and the sensitivity part. Now we will see certain problems related to sensitivity, related to feedback, related to reduction formula, and related to block diagrams. Okay, and using the reduction techniques for block diagrams and finding the simplified block. Okay, overall structure for the given complicated structure. These are the typical problems which are asked in GATE exam. That will be the next topic.